everyone, so in this video I'll show you how to extract potassium carbonate, this stuff, from ash. First of all, I want to tell you that this is an ancient method. People, when soap started appearing, it was made from this stuff. It was extracted by mixing ash with water, then boiling down. And I did a lot of purification steps to make some pure potassium carbonate. But you can do whatever you want. And it was mixed with some cow and animal fats and boiled, and it made soap. So I'm going to show you now this old method on getting potassium carbonate or potash at home. So the branches are just burning. So to extract all of the potassium carbonate from all the ashes, it's 2 buckets, and you might see, oh, so you're going to extract it and boil it down in a pot, right? Well, this contains potassium hydroxide, which reacts with the aluminum in a pan or a pot and destroys it or contaminates it with aluminum hydroxides and carbonates and other stuff. But this has been sitting for a month right now, so it probably mostly has potassium carbonate. So now let's extract this. Water into this ash. Oh my god, it's so heavy. Ugh. So got some more water, about 5 liters. Now, dump this stuff with it. Okay, now I have this blind. Yes, a blind. Yes, I'm using a blind or a curtain. And I have to rip it. Where are my scissors or a knife or something? Too heavy to flip over. Oh, yes! It's working! Okay, so I've got most of the solution. It's a few liters probably. I mean, it's not a perfect yield. There's a lot of the potassium carbonate left in there, but I mean, it's pretty soluble, so most of it should be in here. Now, I'm just kind of tired, so I'm just gonna leave it as it is. I mean, here, at least in my family, we use it as fertilizer because potassium carbonate is used as a fertilizer, and the ash actually contains a big amount of it, and then there are solids which can be used as fertilizer. So I'll probably just pour it in the garden as a fertilizer. I'm going to keep this highly concentrated solution. Now the next bucket, I couldn't do 2 at a time because one of these lids, when I was cutting them, I broke them. So now I'm gonna, whoa, this is so heavy. Like, this is too heavy for me, but I can do this. Ah! Oh my god, this is actually concerningly heavy. Ash and water do not mix well. They turn really. Oh no! Oh no! Oh no! Oh my god, no! 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 Oh my god! Just full of carbon now. Okay, so I've cleaned myself up, and I'm gonna just lift it by grabbing these. Just lift it up and see what's going on, and if it's worth it. Oh my god, it's still unfiltered. It's been so long. How long is this gonna take? I'm gonna scoop it with this cup. It's like a jar. It's like a canning jar with a handle. But oh wow, look how clear that is, and look how quick it's filtering. Okay, so now the solutions are done. As you can see, they're yellow, but my filters ripped at one point. There's some precipitate at the bottom, which is the charcoal because the filter ripped. But okay, I'm gonna bring this inside. I'm gonna see you the next day because I'm not gonna boil this. Okay, hello everyone. So as you can see, it's the next day, and well, first of all, we're outside. My hot plate is smoking for some reason. I don't know why, but it's just probably some I got something on it, so now it's smoking with whatever, just burn off. So now we got our filter solution. I'll pour it into the pot. And we will let it boil. Also, we'll add it into the beaker. Okay, so it's been like a few hours and we were up to 3 to 4 liters, I think. So now we have only like 2 liters, so we lost like a liter or 2 of water, which is kind of bad. Well, I mean, it's in our table or an oil drum painted white. And yeah, let's go. We need to boil off. I want at least a liter of water, and there's 2 liters in these two. So yeah, we're gonna need to boil them until there's only 1 liter, and then filter it, do some purification steps, and then we can boil it down and get our potassium carbonate. You know, I think that I'm pretty good at chemistry, but now I think that I'm kind of dumb because somehow I was pouring the beaker into this bigger 2-liter beaker. This is a 1-liter beaker, and somehow I smashed it. And do you see that? It just cracked the whole bottom, but it didn't crack this thing. I really hit it on here, and it just broke this. Like what? I mean, it's only like $3 to $4, so it's not expensive, but like, yeah, I'm just wondering how did this happen, like. Okay, so now we're gonna filter the solution because there are a lot of precipitates. I don't know what they are. They might be potassium bicarbonate or maybe just carbonate. I don't know. I will just filter. Wow, I think there's a hole in the filter because it's going really slow. So I mean really fast. Okay, so I cleaned my beaker from the solids or whatever. It's kind of sad that it was the 1-liter beaker, but whatever. It's only like €4. So it's not expensive. And here is our filtered solution. It's a little yellowish orange. Yeah, I don't know if this is gonna work honestly because it's yellow and yellow chemistry always fails. There we go. Now we can boil this solution. So now we're actually in the lab, and this is the solution that we boiled down. I'm gonna pour it in this beaker. I'm gonna zoom in. As you can see, the solution is pretty like orangey. I mean, it could be pure, but I'm gonna try to purify it. I saw a video on this on Experimental Madness, where the channel got deleted in 2019 or 20. I think it was 2019 or something, or maybe in early 2020. Now, the Australian chemist Zachary is going by name Mr. Green Guy, but I saw his video before it got deleted, and I remember he used some ethanol or rubbing alcohol or any sort of alcohol because it binds with the organic stuff and precipitates. Oh, look, that's so cool. It's actually precipitating some white stuff out of the solution. Let me show you. Do you see that? It's reacting. Okay, so we got our filtration set up. And we're just gonna filter this orangey solution. Okay, so here is our filtered solution, and I actually took this funnel and watched the solid and somewhat dissolved, but I checked potassium's carbonate solubility is 110 grams per 100 milliliters. I put more than 100 milliliters, at least 200, and there was totally not, it wasn't even 50 grams, so no, that's not potassium carbonate. Now I'll turn on my hot plate and I'll boil down the solution till dryness. Okay, so it's all of it's almost dried, but the stuff in here is kind of brown, and the stuff is that is on the hot plate that got hotter is white. So I think I'll try to decompose all of the organic stuff with super high heat, because I saw a video about one guy trying to purify this. The ethanol helped a little, but it's better just to heat this super hot, and it decomposes and turns all the organic carbon stuff from the wood into like carbon dioxide, and it just burns away. So I'll try that, but first I'll scrape this up and put it in a beaker. Okay, so it started smoking for some reason, and I think it's working. I mean, it's not up to red hot, which is good because it decomposes on 900 degrees Celsius, turning into potassium oxide from potassium carbonate, which I could make a lot of different things like potassium hydroxide, which is hard to get, but this project is only focused on the carbonate. I mean, you could react with CO2 and get the carbonate, but no, I'd rather just not do any more steps. Oh my god, do you see that? That's glowing orange. Oh my god! Huh? Oh my god, this is actually crazy hot. Oh my god, I'm actually scared. What if the hot plate catches on fire? Okay, so I'm kind of tired, so now I'm gonna set up the stand, just use my hand, but we're now in the lab. And I have this powder, which, you know what, I'll set the stand, which some of it is a little white, but it's just a gray powder, so I'm gonna add some water that will dissolve the carbonate again. And I'll filter this solution tomorrow because today I'm too tired, so I'm gonna go home now. Okay, so here is our solution. It was settled out, but now I was bringing it and I shook it a little, so now it's a suspension of carbon. But we will filter the solution and get our pure potassium carbonate. Okay, so we're aside now because, of course, I don't want water vapor making my walls moldy in the lab, so there we go, our solution, just slightly yellowish. It looks better off camera. I'm gonna just boil it down on a hot plate. Okay, so here is our final whitish powdery solid, which I will have to grind in a mortar and pestle. Okay, so I got the small amount of carbonate, and I'm gonna add some dilute hydrochloric acid. It's bubbling because potassium carbonate reacts with hydrochloric acid to make potassium chloride and the carbon dioxide gas in the equation you see above. Now let's do a flame test to see if this is actually potassium. Okay, so to do the flame test, I'm gonna add some alcohol to a dish, evaporating dish, just a little. and I'm gonna light it here. Did you see that? Yeah, in real life it looks pretty pink. On camera it doesn't look really pink, but yeah, there we go. We got some potassium carbonate.